Hello and welcome to this IChemE Global Awards 2021 webinar. My name is Matt Stalker and I'm your host for today's presentations. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely considered to be the world's most prestigious chemical engineering awards. Today we'll be revealing the winner of the IChemE Process Automation and Digitalisation Award sponsored by the Chemical Engineer. This award recognises the best project, process or product to demonstrate excellence in the application of process automation and/or digitalisation within the chemical and process industries. Our awards judging panel has been hard at work in recent weeks to review and rank all of the entries, and here are our finalists. We have Johnson Matthey, a joint entry from Petronas Digital and Malaysia LNG, Petronas Digital, Saudi Aramco, a joint entry from Tianjin University and Loughborough University, and finally a joint entry from the University of Sheffield, Perceptive Engineering and Siemens. All our finalists have been invited to join us today and tell us more about their work and answer your questions. You can get in touch throughout the presentations using the questions box on screen. So let's get started with our first finalist. Representing Johnson Matthey, it's Paul Clark and Philippe de Venin.
Great. Hello, everybody. My name is Paul Clark. I'm the Digital Transformation Manager for the Efficient Natural Resources sector within Johnson Matthey. I'm also joined by Philippe. Philippe, do you want to introduce yourself?
Yeah, hi, my name is Philippe Tevenen, and I'm working as a Global Technical Service Lead for the formaldehyde business and Product Owner for JM Levo.
Great. And we're going to tell you about JM Levo, which is our digital plant analytics platform. A little bit about JM to start with. Johnson Matthey is a global leader in sustainable technologies, and our vision is for a world that is cleaner and healthier. Our main businesses are organized around firstly shaping a new era of clean energy, achieving more from scarce resources, clean air for all, and helping people live longer and healthier lives. Philippe and I both work in the efficient natural resources sector, and we see digital or digitalisation as a critical enabler to all of our goals, and those are around helping our customers get the most from JM technology, and ultimately over time to work with them to help them navigate the energy transition and start to decarbonise their processes. All of the projects that we run, including JM Levo particularly, take a customer-first approach, and that means that they're drawn from what we hear and what customers tell us about their biggest challenges, and that is often around optimizing performance and thus reducing emissions as business situations change, planning for maintenance or planning for turnarounds, or training and maintaining knowledge in their operators. And we actually see the real value from digital comes where you bring different aspects or different technologies and approaches together to provide a single kind of offering or platform, a bit like JM Levo. It's often what we've learned is, it's not just a case of having the answer, providing the advanced models and the automation, but also being able to bring to bear knowledge, connectivity, and think about the customer experience as well, because as I said, it's not just about having the answer, it's also how do you support customers to embed a new way of working in their operations and therefore make more informed decisions about optimizing their plants. So it's really about how all these things come together. JM Levo is hopefully a really good example of this, and it's around our vision for a data-driven partnership between JM and our customers. We started out a few years ago with a goal to take the high quality technical support and service that JM has always provided, improve on it, and bring to bear not just the additional value you can get from advanced analytics, but also improve the access, the customer experience, and the way people get in touch with JM in a more timely way. We started in formaldehyde. We're just about to launch our methanol offering, and we've got more markets to follow. And I'm going to hand to Philippe now, who's going to talk a little bit more about the JM Levo formaldehyde offering.
Yeah, thank you, Paul. So as you said, for the formaldehyde offering, we've been working with customers since about like 40 years back, getting the data to help them optimizing the plant. And with JM Levo, we have taken a new approach, making the data sharing much easier and having better tools to use all the data we have accessible feeding the data to machine learning models to optimize the plant, using the similar data for helping the customers in planning to make sure they have a smooth production and with no interruption. And this has been launched more than a year ago now, and we successfully, and I think we can go on the next slide, Paul. So we will see a concrete example how this has helped our customers. So on the charts here, we have highlighted on the top charts how the performance is with the comparison to the actual yield on the methanol consumption, where 1 is the average. And on the bottom charts, we have how the plant has been used and producing formaldehyde. With the higher production rate would require higher methanol consumption. And we can see what the orange dots represent when customers have been starting using Levo, how not only they manage to operate the plant at a higher rate as they need, or they would have, but as well as how the methanol consumption has decreased by having managed to reach a much higher yield than before. So they've been managed to produce formaldehyde in a slightly more sustainable way by reducing the methanol consumption. And like Paul mentioned earlier, we've seen as well how this transition to a more digital world has changed the culture of the customers and impact their behaviors. They have started to provide data more frequently. So going from once a month or less to weekly. They've been using this optimization tool, which is where there is a machine learning model and other models behind to provide the recommendations on how to optimize the performance of the plant. And it as well strengthened the interaction with the GEM technical support team, which I think is all the benefit they realize now is a combination of all these interactions and optimization tools. And the feedback from the customers has been very positive. I think we have about more than a dozen customers using it now. And the feedback is very positive, and they all acknowledge how it has helped them to optimize the plant, making the operation safer, steady, and reduce the methanol usage. Next one, I think that's. So that was on the experience with GEM Levo formaldehyde and how we've digitized the technical support.
Great, thanks.
Okay.
Thanks, Philippe. Thanks, everybody.
Thank you very much, Paul and Philippe, for getting us started. So we'll now turn to Q&A. So if you haven't already, now is the time to get in touch via the questions box. And while we pause on that and give you a moment, don't forget there are more IChemE Awards webinars coming up throughout the next couple of weeks. You can find all the dates and times by visiting our website. That's icheme.org/global awards. Right, we don't appear to have any questions, so thank you very much, gentlemen. We'll move on to our second finalist. Next up, representing the joint entry from Petronas Digital and Malaysia LNG, please welcome Lee Kien Seng. We just need you to unmute yourself, Lee.
You guys can see my screen and webcam, right?
Perfect, thank you.
Cool. Yeah, so hello everyone, my name is Lee Kien Seng. I'm a product manager from Group Digital Petronas. And today I'm pleased to share with you an in-house developed solution, which is Stella, and it's an acronym for Startup Excellence Life Advisory. So if you have any questions from my presentation, feel free to drop them in the chat, or you can, if you're watching this on demand, you can contact me via the contact details below. So throughout my presentation, I'll be sharing the North Star and the product goal of Stella, and then I will unveil what is under the hood of the AI-driven Life Advisory. After that, I'll share about some of the achievements unlocked during actual startups, And then lastly, we'll close with some of the shareholder feedbacks that we've received for the solution. So Stella was created with the mission to capture the tacit knowledge in order to enable consistent and smooth startup of entry trends. The problem that we are solving is the inconsistent startup performance observed because of different approaches used by different operators based on their individual experience and tacit knowledge. Now, to capture the tacit knowledge of the skilled operators is a very complex endeavor. This is especially true for startup knowledge because turnaround does not happen throughout the year and the operators are under intense stress during the startup itself. So we envision to have a solution that can capture this valuable tacit knowledge and then provide advisory to our panel operators during a startup. Hence, we came out with Stella. It is our Startup Excellence Life Advisory. It's an AI-driven life advisory that provides real-time recommendation of the parameter adjustments to our panel operators in response to actual plant conditions. It uses machine learning algorithms to harness data insights from all the startups' executions in the past 20 years, which has around 3.4 billion data points from over 1,800 sensors. It also incorporates the tacit knowledge from our skilled operators and engineers to the advisory. Stella was built for these three key personas. Our panel operators would like to carry out the plant startup following the validated tacit knowledge and best practices so that hiccups and potentially costly mistakes can be avoided. Our process engineers would like to then capture the tacit knowledge of our skilled and experienced operators in starting up the plant so that the capabilities can be passed on to the new team members. And as for our shutdown manager, he would like to achieve consistent and optimized startups so that the startup activities duration can be predictable for scheduling optimization, leading to higher plant utilization and more production. So we are pleased to share that Stella has been successfully implemented in 5 trains in our Petronas entry complex, which has 4 plants, 9 trains with a total capacity of around 30 million tonnes per annum. So the results is something that has been very promising, and I'll be sharing that shortly after we go through the details of the solution. Now let me unveil what is under the hood of the AI-driven life advisory. If you look at the Stella engine box in the middle, you'll see that there are 2 main components. The first one is the predictive model, and the second component is the optimized operating parameter recommendation model. The predictive model is a model that is built by the historical data that I mentioned just now, the 3.4 billion data points from over past 20 years of operation. It learns the relationship between our input controllable parameters, such as the flow rate, valve openings, pressures, and temperatures, and the corresponding main cryogenic heat exchanger temperature and temperature rate of change profile. Now, by having this predictive model, we will be able to predict and simulate what will be the corresponding results if we were to control the parameters in a certain way. So this was heavily used by the operators and also engineers to simulate under different conditions what will be then the best approach in starting up the plant. Now we then further augmented the model with an optimized operating parameter recommendation model, which will take in the actual live data from Pi and then leverage on the predictive model in order to generate what will be the best advice or the best controllable parameter adjustment that the operators can follow in order to achieve an optimized startup. So it provides the output in terms of controllable parameters adjustment, such as opening the valve to a certain percentage or maintaining the pressure at certain bar, and what is then the corresponding results that we will be able to observe if the parameters recommendations are followed. Now with the predictive capability, we could also forecast and generate reminder to the operators that this task is about to finish in say another 2 hours, and then they can coordinate with the few operators on the upcoming steps. Now at the bottom are just some of the screenshots of the user interface itself. So basically we have a diagram to summarize what are the key process parameters to be observed, and then in the middle you'll see that's where the operators will put in what are the target configuration, target process parameters adjustment. And then lastly, we'll generate the advisory in both tabular and chat form for the panel operators to refer to during the startup. Now, some of the results that we have achieved while using Stella in the actual startup of LNG plants. So far, we have already deployed the solution to 6 startups. And as you can see, we have achieved very promising results. Out of the 6 startups, 5 of them actually achieved the best performance in the history of the plant. And then all of them has actually led to significant saving in terms of duration that will allow more production and higher plant utilization. Now, some of the feedbacks that we received from the stakeholders, we're happy to hear that the CEO of MNG actually applauded the team for having the courage to innovate this plant startup approach, changing how things used to be done for the past 20 years, leveraging on digital and leveraging on big data analytics. The operators himself were also very impressed with the results that have been achieved by Stella. So he was already telling us that it's the best pre-cool down that he has carried out so far, and the advisory given actually helped him to achieve the optimum parameters and optimum values. And our area managers, Proxy was very happy that we managed to achieve 5 historical best pre-cool down on startups. And then the process engineers were also very excited that in his plant itself, we managed to achieve 3 startups with repeatable and consistently superior results. And we have also heard that the digital innovation has finally then reached to the operation team in advising and improving the solution, improving the plant operation instead of really focusing on just the work processes related use cases. And lastly, our shutdown manager was also happy that the solution can help to consistently optimize the startup duration. And this has also helped to capture all the valuable tacit knowledge and the study that's been done so far. And we are also very proud to share that the product has also won GasTech Awards 2021 in Engineering Partnership of the Year category. And earlier of the year, we have also won Malaysia Technology Excellence Award 2021 in Analytics Oil and Gas category. And right now, as everyone is aware, we are shortlisted for IChemE Global Awards in Process Automation and Digitalisation category. And next week, we'll also be sharing the product under team category. And before I end my presentation, I just want to give a shout out to the team members behind Stella, coming from both Malaysia LNG and also Petronas Digital's Rian Berhad. So without the effort from all the team members, we wouldn't be able to achieve the stellar results that we have seen just now. With that, that's all for my presentation. If there's any questions, I'm more than happy to answer.
Okay, thank you very much, Lee. So once again, we'll pause for a moment to give you a chance to type your questions if you want to get in touch. You can do that through the questions box on GoToWebinar. And while we give you a moment on that, if you're watching this live, there's still time to register to join us for our Advances in the Digitalisation of the Process Industries virtual conference coming up later this month on the 20th and 21st of October. You can visit IChemE.org/advances2021 for more information. We do have our first question. Does this technology also consider the feed variation?
Yeah, so in this case, because this is really focusing on the startup of an LNG plant, so the so-called feed or the gas that's being used for the pre-cooling down process is in a way consistent. So there's no deviation in terms of what kind of composition are we actually using.
Okay, thank you very much. That's all the questions we have, so we're going to move on. Thank you very much. We'll now move on to our third finalist of the day. It's another entry from Petronas Digital. Please welcome Mohammed Farhan Kamaluddin.
Hello everyone. Just checking, are you able to see my screen?
Yes, we can, and we can hear you loud and clear.
All right. Well, thanks. Okay. Good morning, everyone. Allow me to introduce myself. My name is Farhan Kamaluddin. I'm the product manager for Citizen Analytics program. And today I'll be talking to you about Citizen Analytics program in Petronas Digital. All right, so let's begin to when it all started. So CA was Citizen Analytics program, or as we fondly call it CA, was actually born from the need to scale to more projects faster. We're building a strong data-driven culture within Petronas. And initially, we have about 100 data scientists in Petronas, but we think that that also won't be enough to drive the data-driven mindset and culture. So with that in mind, we thought of what if we can actually democratize data analytics and also the culture within Petronas using a program. So this was the basically the birth of this Citizen Analytics program. And that was the pivotal point that drove this program ideation and also creation. And we first piloted this program back in 2019 with a group of engineers from Petronas downstream plants. So from there, our team gathered valuable feedback from the first cohort, and we enhanced the program better in order to scale it by dividing it into 3 levels. We have analytics awareness, which covers the basic advanced analytics skill, and then analytics translator, which give hands-on trainings to use Microsoft Power BI, and then analytics practitioner, which allows the participants to explore the sandbox environment using the Azure ML Studio to develop their own analytics solution. So those are the 3 training sessions. And we also transitioned from having it in from classroom learning into virtual learning starting last year due to the pandemic. And in the future, we are looking at having it in the format of e-learning as well, so that can allow our participants to learn about analytics skills through their own pace. Okay, so what unique about this program is that it is not just a training program, but it is also an upskilling program in which we feature coaching and also mentoring to our participants post the training completion, meaning that they can go to their coaches to seek guidance and also help in developing their analytics solution or Power BI dashboard. Okay. So this is how we upskill our participants through Citizen Analytics. So for Citizen Analytics projects, we start off by identifying a problem that is relevant to the domain, and then we determine what data that is available, and also the subject matter experts will be assisting in that. So they will identify the challenges that will be relevant to the domain and use that as part of their business proposal, use case proposal. And then the subject matter experts, the SMEs, will also leverage on the Power BI and also Azure ML tools to build analytics solution. And this basically means that the domain knowledge expert that already have the in-depth understanding of their data relationship to the problem is the one developing the solution. So basically the solution that they build is very tailored towards what their business needs. So once they have developed the solution, it will be subsequently adopted and implemented to resolve the initial pain points that they have. Okay, So this end-to-end problem solutioning basically takes place through a guided hands-on approach given by our coaches and will be delivered by adopting the agile methodology as well. So the real value from this program, CA program, actually comes from helping the business by unlocking their potential value. So what it means is that by using Power BI, our participants will be able to perform descriptive analysis, and they can land on the right decision to be made based on the data visualization and also the insights trending that was generated from their report and dashboard. And if we couple that as well with the Azure ML modeling, participants will be able to perform predictive analytics, such as solving linear regression problem or classification problems, and they can use it as a solution to their business problems based on the machine learning model's result. So all of these, again, as mentioned, are developed through iterations using agile methodologies in which participants develop incremental solutions in sprints. So this framework in citizen analytics has actually translated to improve productivity and also work efficiency, better reliability that allows steady operations, and for some, they will also manage to obtain cost savings and also cost avoidance from the improved work processes. So some of the personnel that have benefited from the program include the plant engineers or chemical engineers who wants to ensure that their measurement readings are not faulty. We had some of the engineers who use this to predict their online analyzer reading so that they can have it as a secondary backup measurement. We also have IT specialists that use Azure ML Studio or Prediction to analyze the cloud storage required for the organization in the coming years. For the finance professionals as well, we have them. Some of them improve the profit and loss reporting with better and more dynamic report. And finally, we have business analysts who wants to start modeling the complex data without extensive coding knowledge. So all of these people, all of these personnel come into citizen analytics program, and they have upskilled themselves to, in the end, develop Power BI report and dashboard, and also the CA, the machine learning solutions. And we also have many more personnel in this. These are just some of the prominent ones that we see in our program. So, so far our journey has taken us to great achievements. We have about 9,500 participants across the whole group of Petronas, and we are looking at around 61 departments and also business units across Petronas group wide. And we had conducted about more than 100 training sessions, which have benefited all of these participants. And we also have more than 150 coaches from Petronas Group Digital. And even now, we also have coaches from multiple business units as well through our Train to Trainers program. And we have built around more than 400 Power BI reports and dashboard, and around 110 analytics solutions using the Azure ML Studio. So in just one final one before we end the session, as mentioned, there are 3 levels of training programs that are offered under the CA umbrella. So the first one is on analytics awareness, which basically aims to bring awareness and basic understanding on data and analytics techniques to our Petronas staff. It is covered within 2 half-day workshop sessions. And then once participants have completed this journey, they will move on to level 2. We call it Analytics Translator. And in here, we wanted to increase proactive monitoring and also data visibility via dashboard visualization. And participants will be having hands-on session on Power BI. And at the end of the training sessions, they will be going through 3 sprint assignments delivery, in which they can seek for guidance and also assistance from the coaches that are assigned to them. And last but not least, our third training level is Analytics Practitioner. So Analytics Practitioner aims to solve the operating unit or the business specific use case via data analytics and also modeling. And this is very comprehensive training session that covers around within the span of 4 days, and at the end of it, the participants will also develop their own business pain point solutions towards their own business pain points. These are all developed by the participants with the assistance of the coaches from our data science group. So what's next is that now that we have all of this ready and in place, our team aims to scale the adoption to 50% of the organization of Petronas by the end of 2023. And along the way, we'll also identify more opportunities within businesses to help them realize their full potential using analytics, and then share the learnings that we have gathered so far from this program to facilitate the learning journey, be it in the citizen analytics scope or other digital skills. So with that, I end my session. Thank you.
Thank you very much. So once again, we will take a pause for questions. If you'd like to get in touch and haven't already done so, please use the questions box now. We do have our first question. What advice would you give to another organisation about to embark on a similar project?
Yeah, so basically my advice would be start small. We started with a pilot program. We wanted to test out this idea on whether we can actually democratize the analytics skill. And then once we get support and business buy-ins, then we can start looking into making it bigger. And this can also be assisted through a lot of partnership and also alliances with other digital giants as well, such as Microsoft or Google. If we can have one platform that we can leverage on, and it's easy to use by our participants, as well as following the company standard and guidelines and governance as well, then we can utilize that tools to help democratize this practice to the whole organization.
Okay, thank you very much. We're going to move on to our next presentation. We still have 3 more finalists to hear from before we announce our award winner. So let me introduce our next speaker from Saudi Aramco. It's Fawaz Al Sahan.
Thank you, Matt. Can you turn my camera on, please? Okay, perfect, appreciate it. Okay, let me try to. Okay. Can you see my screen?
Yes, we can. Yes, we can hear you loud and clear.
Thank you so much again, Matt. Assalamu alaikum. Assalamu alaikum and greetings everyone. My name is Fawaz Al Sahan. On behalf of Saudi Aramco team, Omar Zaid, Fawaz Al Hadlak, and myself, Fawaz Sahan, I would like to present to you our innovation smart dewatering system. I will start with an introduction on tank dewatering. Then I will describe the first component of smart dewatering system, the sound velocity dewatering system. I will describe next the second component, the multi-layer flow and level visualizer, the smart dewatering system setup and operation, and the advantages will be highlighted. We'll end my presentation with a few points. Why we need automatic dewatering? Basically, I'm sorry, there is some noise in the background. Basically, we need automatic dewatering to address known challenges in oil industry, to mitigate hydrocarbon drainage, basically to drain water only, eliminating water overflow and preventing upset to downstream plant operation, mitigate corrosion of the tank bottom plates, eliminate manual dewatering, which requires many plant operators and a lot of time, minimizes manual water interface measurement and the need for the plant operators to climb the tanks to take this measurement. Here is the solution to address these highlighted challenges. Smart dewatering system, which consists of 2 components, the sound velocity dewatering system and the multi-layer flow and level visualizer. Allow me to elaborate on the first part, which is sound velocity dewatering system. Sound velocity dewatering system consists of a smart sound velocity sensor, non-intrusive or intrusive, a control system, and an automatic control valve. Sound velocity dewatering system is a patented technology with built-in analytics, providing 3 parameters: the drain flow, the media recognition, and the drain valve status, whether the valve is healthy, stuck, or internally leaking. The system can be easily adopted, again, because it can be non-intrusive, to provide an automatic dewatering operation. As each fluid has a recognized sound velocity, the sound velocity dewatering system measures the sound velocity and recognizes the media in the drain pipe once the drain valve is open. So first the valve is open, then the drainage cycle will start, and the sensor, the sound velocity sensor, will start recognizing the type of media to allow the operation of the flow ongoing or to stop it once any hydrocarbon is detected. The system was deployed in Saudi Aramco. The slide showing one drain cycle. So when the drain cycle starts, the drain valve will open and the water is drained. When the sound velocity drops below a preset value, depends on the sound velocity of water versus the hydrocarbon stored in that tank, the valve will be then automatically closed. The slide here is showing the first complete deployment of sound velocity dewatering system, which was done in 2010 at one of Saudi Aramco facilities, Riyadh Refinery. The multi-layer flow and level visualizer is the second component of the smart dewatering system. The multi-layer flow and level visualizer consists of an array of sound velocity sensors or other type of sensors. Multi-layer flow and level visualizer is a granted and a patented technology which provides 3 parameters: the total level inside the hydrocarbon tank, the water interface, and also the temperature measurement. It's worth highlighting that the multi-layer flow and level visualizer scope and the patent goes even beyond the tank dewatering application and include other interface applications in the upstream operation of the oil and gas. Multi-layer flow and level visualizer is made of ultrasonic sensors, sound velocity sensors, or others, again, array of sensors. A very simple setup is a couple of pressure sensors at different heights, or basically electromagnetic signals through a probe. Using the pressure measurement setup, the accuracy was measured and found to match the manual interface measurement, as the graph on the top is showing. Also, the total level measurement was matching, and the graph on the bottom of this slide is also showing a comparison between the interface measurement, the automatic interface measurement, the total measurement, and also the existing tank gauging system, which also display the total level measurement. Moving forward, let us now combine the 2 components together to build the smart dewatering system. The smart dewatering system is a filed patent which can provide up to 7 parameters: the total level, the interface water level, the fluid temperature, hydrostatic pressure, the flow measurement, the drain media recognition, and also a very important input is the analytics around the drain valve to indicate whether the valve status is healthy or not. Smart dewatering system was put in operation in June 2021 with the results meeting the expectations. The slide here is reflecting the system in operation with specific parameters which are monitored, like the valve opening, the sound velocity, and the interface measurement. Smart dewatering system provide many advantages to oil and gas industry, as we have captured ourselves. Improving the safety by ensuring zero hydrocarbon drainage to oily water sour. Support the health of operators working around that system. So no more manual drainage, no more climbing tanks to take the interface measurement. Smart dewatering is an IR 4.0 enabler, which built from smart sensors and also uses data analytics. It addresses the crude quality and hydrocarbon losses. It prevents water overflow to the downstream units in the plant and also to the customers. Cost optimization was very much recognized, especially when we start comparing the conventional solution versus the smart dewatering solution. It's a simple design which can be adopted in running hydrocarbon tanks, which is again another advantage which we have seen when we start the pilot and even when we start the deployment in different facilities. Smart dewatering journey started in 2010 with the pilot and the first patent filing. Smart dewatering has 3 associated patents and wins so far many awards from Saudi Arabia, like the King Award, from Saudi Aramco, the Gulf Engineering Union Award, and international awards like ISA Excellence in Innovation Award. We are also very honored to be in the IChemE 2021 finalist for 2 categories, process automation and digitalization, and also for the oil and gas. To conclude, let me highlight a few points. Smart dewatering system is a digital transformation technology with 3 associated patents. It supports safety, environment, and health. Smart dewatering supports recycle economy and net zero by eliminating the hydrocarbon losses and emissions. Smart dewatering provides a simple and a cost-effective solution for automatic water drainage and also monitoring the drain valve condition. Before I end my presentation, I would like to thank the Institute of Chemical Engineers for listing our innovation, smart dewatering system, as a finalist in the 2 categories, process automation, digitalization, and also for oil and gas. This is truly an honor for us. Also, thank you for the opportunity provided to us, Omar Zaid, Fawaz Al-Hadlak, and myself, Fawaz Al-Sahem, to present our innovation to this great audience joining us today. And this is the end of my presentation. Thank you.
Okay, thank you very much. Once again, we'll take a brief pause. If you have a question, please get in touch now using the questions box. Okay, we don't appear to have any questions, so thank you very much, Fawaz. We will move on to our next presentation. Representing Tianjin University and Loughborough University, please welcome Qi Zhao.
Can you see my slides?
Yes, we can, and we can hear you loud and clear.
Okay, yeah, thank you very much. And hello, everyone. I'm Qi Zhao. I'm from Tianjin University, and thank you very much for having the opportunity to present our project Fuel Cell Engine Simulator here. And this project is in collaboration with Loughborough University, Professor Jin Xuan, and I will be presenting on behalf of all of us. So here are the PI. One is me, and one is Professor Xuan. He's from Loughborough University, head of the Department of Chemical Engineering, and he's also the director of the UKRI Interdisciplinary Center for the Circular Chemical Engineering. So here's a little background here. Hydrogen and fuel cell engines are actually very important for the future carbon-free transportations. And they are clean and carbon-free, with high energy density and short refueling time. So the most critical issue is the design and development of fuel cell engine for the. And we know that fuel cell engine is a multi-scale electrochemical and thermophysical process for the fuel cell engines. So it is very complicated. So the fuel cell modeling and simulation will be very, very important for the development of fuel cell engines. That's why we together created the fuel cell simulator for the development of fuel cell engines. So what we have done generally, I will develop a set of fuel cell simulators. For the first one is a fuel cell 3D model. The 3D model actually can represent the real structure of a fuel cell engine with its flow field and with its all the heat and mass transfer and chemical processes. And so this tool can be directly used to design the flow field, for example, how the stack look like, and how do we design the flow channel, the cooling channel, the plate, and how the performance is based on different design. So it's a very powerful tool that people can use it for the direct design of fuel cell engines. Of course, this model has been fully validated with experimental data comprehensively, not only for the performance output, but also for the distributions, because we know the 3D model actually tells us the distribution inside the fuel cell. For example, for different temperatures and different current densities, for voltages, and how the current density distributes, we compare it with comprehensively with experimental data, so that we believe it is a very reliable model. And we also coupled this 3D model with AI technologies to create the so-called fuel cell digital twin platform. The idea is that the 3D model can create lots of data for the multi-physics inside the fuel cell engine, and those data can be used to train a machine learning model, so that we can actually quickly predict the more multi-physics distribution inside the fuel cell engine and help us to optimize the fuel cell design. For example, how do we change the catalyst layer composition? How do we design a better fuel cell by combining the traditional CFD technology with AI technology? And based on the 3D model and AI technology, we have proposed some novel designs for the fuel cell. For example, we have proposed a novel dot matrix cathode flow field with this diamond-shaped flow field. We have compared with a traditional flow field, showing that it has a better performance, but with a lower flow resistance, which is very critical for the development of fuel cell engines. So not only for the 3D model for the structure of the stack, it is also very important to design the microstructure of the electrode. We know that in the catalyst layer we have a nanoscale pores, and in the gas diffusion layer we have macro scale pores. So we have developed our own platform to generate those structures firstly, and then do the optimizations. So we have generated different generation methods. For example, to generate the macro pores layer with the different carbon powders, to generate the carbon fiber papers, and also to generate the catalyst layer with platinum carbon and ionomer structures. So with this technology, we are able to generate whatever we want to represent in the real nanoscale structures of the electrode, and then we can do some simulation to analyze the processes inside it. For example, with after cell assembling, how those microstructures are compressed by the bipolar plate, how the microstructure changes, and also during the operation, how the water is reproduced inside the nanostructure, and how can they be removed through those electrodes out of the fuel cell. So that will help us to not only design the stack structure, but also the electrode structure for the fuel cell. Another simulator we developed for fuel cell is the 1D and 2D models. And this model is generally for the control strategy and the transient operation of fuel cell. And it is good for example, the hydrogen recirculation operation, the cold start during the winter, that the fuel cell with water, with oxygen and hydrogen reacting, producing water, may forming ice, freezing inside the cell. So that this dynamic model can help us to optimize all the control strategy. How can we dynamically control the fuel cell well to facing those transient operations? And we also have developed a fuel cell system model together with the fuel cell, not only the fuel cell stack, but also with other system components. For example, the air compressor, the hydrogen compressor, the humidifier, the thermal management system, so that we can provide a system level simulator for people to optimize the fuel cell system. So with this complete fuel cell simulator, those models have been comprehensively implemented in the industry, but not only in China and the UK, but also in other countries. For example, we have been collaborating with Bosch for 3 years. Our model has been comprehensively used in the design for the fuel cell stack in Bosch, and also in Yutong Great Wall Motors, SEC Motors, and for almost, I think, about 20 companies all over the world have been using our fuel cell simulator for their fuel cell engine development. And we have also been leading some national and industry projects for the design and optimization of fuel cells. So with this kind of a fuel cell engine simulator, we not only help the industry to develop their products, we can also propose a future trend for the fuel cell engine development. For example, people have realized that we have to increase the power density of the fuel cell engine from 3 kilowatts per liter to 9 kilowatts per liter in the next 10 years. But how can we do that? In this way, the fuel cell simulator will be a very good tool for us to see how can we achieve this high power density design, so that based on our fuel cell models, we have provided detailed and quantitatively technical index of the components, how each component can be optimized and can be redesigned to reach the high power density requirements for the next generation fuel cells. And this work has been recently published in Nature for a 9 pages long article. And myself and Professor Xuan are the first 2 authors and the corresponding authors for this paper. So that's generally the brief introduction about our work, the virtual fuel cell simulator work. And thank you very much.
Okay, thank you very much for that presentation. We'll once again pause for just a moment to take any questions. If you'd like to get in touch, please use the questions box. And while we give you a moment on that, don't forget the winner of this award will have a chance to lift a second prize before the end of the month. All of our team award winners qualify as finalists for our top prize, the Outstanding Achievement in Chemical and Process Engineering Award. We'll be announcing the winner of that award on Friday, the 15th of October. There don't appear to be any questions, so we're going to move on. Thank you very much. We have reached our last presentation of the day. This is a pre-recorded presentation on the joint entry from the University of Sheffield, Perceptive Engineering and Siemens, but Mo Zandi from the University of Sheffield will join us after the video for Q&A. So once again, please feel free to submit your videos.
Thank you very much, and hi to everybody.
Hello, I am Professor Mo Zandi from the University of Sheffield. This is a double act presentation, and alongside my colleague, Dr. Eduardo Lopez Montero, Senior Engineering Consultant at Perceptive Engineering, is helping me to share the project results with you. The University of Sheffield installed a world-leading pilot plan within the Faculty of Engineering in 2018. It is named the Diamond Integrated Pilot Plan, or for short, DEEP. DEEP is capable of manufacturing pharmaceutical tablets from blends of model active ingredients and inactive media. This includes key powder process steps for formulated products manufactured, such as crystallization, blending, granulation, and tableting. The new continuous powder processing plan emphasizes the importance of complex particulate products and formulated products more broadly in modern chemical engineering, and we are also reflecting this in our new curriculum in chemical engineering. It is truly research-led teaching. DEEP's key features include a dedicated industrial control room to accommodate an advanced control system and a digital twin of the plant. The continuous powder processing plant in DEEP, including the continuous crystallizer, were provided by different manufacturers and vendors, and also were not IoT enabled. University of Sheffield, Perceptive Engineering, and Siemens joined forces to develop an innovative solution to digitalize the whole continuous drug manufacturing process from crystallization to tableting machine, and converted into the world's leading Industry 4.0 demonstrator. The main objective of the project was to adopt a data-centric approach and automation, and to demonstrate facilities to test and validate potential IoT applications in the real world.
In this slide, we list the challenges and goals of the project. The challenges or previous state of the pilot plan included a low digital process maturity. In other words, the pilot plan was not IoT enabled. Each system and process unit represented its own isolated data island. Therefore, data had to be locally saved on separate locations and then brought together manually for offline analysis. Also, existing knowledge from technical personnel could not be fully leveraged when controlling the processes, ultimately making the operation of the pilot plan highly manual, resulting in a considerable workload on operators. Therefore, the University of Sheffield wanted to develop a solution that could improve the system operation and overcome these challenges. The main goals of the project were to marshal and align all data from the different systems in a centralized location, develop dashboards for monitoring the systems locally and remotely, a solution that could use all the data in real time and is able to use machine learning techniques to model, predict, and ultimately control critical process variables. Also, to implement a solution that can upload in real time all data to Siemens MindSphere, so the data can be used across the university for data science research activities. The first task for the development of the control system for the pilot plan was to set up the digital architecture. This architecture can be summarized in this block diagram. Essentially, Perceptive's FarmMV software was used to read and write data to and from all sensors and process units, including Siemens MindSphere, and the software used to run the digital twin. This facilitated access to all data from a single interface. This digital architecture enables a synergy between statistical and nonlinear models, providing a complete set of tools for monitoring, advanced process control, and machine learning, a seamless integration with process units and PIT instruments, and also enables data fusion and alignment across the full platform. After FarmMV was set up as the single point repository for all equipment's data, the optimized experimental design platform was configured for each of the process units at the Diamond pilot plant. The OEDP is a solution built upon Perceptive Engineering's FarmMV software and provides the workflows and tools for rapid process development using optimized experimental design techniques. These techniques include automated design of experiments, machine learning for self-optimization and automated model adaptation, response testing, and integration with mechanistic digital twins for development and deployment of advanced process control. The OEDP includes pre-configured tools and embedded documentation to reduce overall configuration and development effort. All these tools can be accessed via interactive dashboards, so operators at the University of Sheffield can navigate across all the process units, drill down to specific parts of the system, and activate any of the digital tools using such interactive dashboards. The platform also supports user authentication with different levels of access. For example, users that are only allowed to monitor the system, to administrators that can trigger APC and make changes to the OEDP solution. In summary, the OEDP enables smart process development for the crystallizer, filter dryer, and the continuous tableting line. The current slide shows how a model can be identified to predict the torque of the twin screw wet granulator. Statistically rich data for modeling torque dynamics can be generated using the OEDB's response test tool. Then, through machine learning techniques, the platform is able to identify the model automatically and also to adapt the model to new operating conditions if needed. An example of an automated step test is displayed in the right-hand side of the dashboard. Real-time torque measurements are displayed in green on the top trend. The other trends show in red the steps applied by PharmaMV and in blue the readbacks from the process variables. These data are used in real time to adapt the model, and after a predefined time has elapsed or a model accuracy level is reached, the automated modeling stops and the new model is integrated within an MPC architecture to control torque to set point. Operators can activate and configure the automated model adaptation via the panel at the left-hand side of the dashboard. The platform will continuously monitor the quality of the data and will notify operators of any interface communication errors. The platform will stop any response test or DOE if such communication errors are detected. It is worth to mention that the data from any automated response test is uploaded to MindSphere in real time to allow scientists across the University of Sheffield access to the data for analysis and research activities. One of the main goals of the project was to upload the data in real time to MindSphere, which is Siemens' leading industrial IoT as a service solution. Two Siemens nanoboxes were interfaced to PharmaMV to enable the possibility of pushing data from all process units to the University of Sheffield's MindSphere account. The screenshot in this slide shows how data from the crystallizer unit operation is collected by PharmaMV and then uploaded into the cloud in real time. The data can then be accessed both online and offline by students and scientists at the University of Sheffield.
The importance of big data visualization as a tool for Industry 4.0 is widespread and well documented. An example of the benefits of this project is the integration of web-based data visualization tools such as Wiz through MindSphere. To give both industry and academia access to the data, here Wiz provides a one-stop shop for data analysis and visualizations. Scientists and non-scientists can use the platform to better understand the data, analyze it, and make informed decisions.
This is a summary of the benefits of the digital pharmaceutical manufacturing solution developed for the Diamond pilot plant. The digital control system allows to adopt a data-centric approach and automation, making knowledge about formulations, process and manufacturing of pharmaceuticals accessible and reusable. Enables a cost-effective experimentation with production-class operational equipment without the costly downtime and reduced output if that were to be done on actual production machines. Provides an opportunity to access and optimize low-level control systems in a pre-competitive environment and allows development of a service-oriented business model. The digital control system was developed on Perceptive's PharmaMV software, which provides a full suite of analytical modeling and APC tools for rapid process development and optimization. It allows fusion and visualization of process and analytical data in real time. For the pilot plant, PharmaMV enables the prediction of critical quality attributes using data-driven models and digital twins. It also enables the implementation of model predictive control for CQAs and can be interfaced to Siemens MindSphere to transfer data in real time to the cloud. Some of the main benefits of this digital control system are that it provides the university with a demonstrator of a state-of-the-art automation using an industry-proven 21 CFR Part 11 compliant platform, delivering a practical learning experience of an industrial continuous powder processing plant to undergraduates and access to manufacturing plant equipment to research teams. It provides automatic data fusion and visualization using multivariate trends, charts, and interactive dashboards, automated execution of DOEs, process response testing, which reduces operators' workload and streamlines data generation for optimization, analysis, and research. Online model adaptation using machine learning techniques allows the evaluation and deployment of process condition monitoring, APC, optimization, and soft sensing approaches. and enables cloud connectivity of all process units to support research and development across all data science activities.
This project was a team effort, and I would like to acknowledge and thank all the colleagues who were involved and supported the project. Without them, the project couldn't happen. I would like to thank all the colleagues from Perceptive Engineering, University of Sheffield, and Siemens. Also, I would like to thank Eduardo, and thank you for your time and giving us this opportunity. Thank you.
Okay, thank you very much for that pre-recorded presentation. Mo is with us, so if you have any questions, now is the time to type them into the chat box.
Thank you, Matt, and then I'm happy to take questions. Thank you.
Right, we don't appear to have any questions, so thank you very much, Mo. I think everybody wants to get on to the moment we've all been waiting for and find out who the winner is. So before we do that, I'd like to thank all of our finalists for joining us today and taking the time to share more information about their work. I'm sure you'll agree, a fine, diverse range of projects on show. But let's start by announcing our highly commended entries, and they are the joint entry from Tianjin University and Loughborough University and Johnson Matthey. So well done to everyone associated with those projects. But now it's time to announce the award winner. Ladies and gentlemen, the winner of the IChemE Process Automation and Digitalisation Award, sponsored by the chemical engineer, is the joint entry from Petronas Digital and Malaysia LNG. So congratulations to everybody who worked on our winning entry. Lee, I hope you're still with us. If we can get you back on screen, or at least microphone, tell us, how does it feel to be an IChemE Award winner?
Hi guys. I mean, we really didn't expect this. You know, we have already celebrated after hearing that we made it to the finalists of IChemE Global Awards. Really credit goes to our passionate team members who have worked tirelessly to make Stellar what it is today. And I'm so proud that we have achieved something that hasn't been done before, and also recognized by such a reputable global professional institution like IChemE. Thank you, IChemE, for providing us with the platform to share our AI solution to the wider audience, and also learning from all the other finalists today. Thank you so much.
Well, congratulations, and thank you to everyone for joining us today, especially all of our finalists. We've still got plenty more IChemE Award webinars to come this week and next week. We're back this afternoon with our Industry Project Award, but that's all for today. So thank you for joining us, and good morning.